Estimating the amount of wire needed for a 3,000 square foot house involves considering various wire types and their respective lengths. These estimates are approximate and can fluctuate based on factors like the house's layout, electrical system design, and specific needs. This estimation will provide a general idea of the quantities of different wires you may need. First, consider 14-2 wire, which is commonly used for lighting circuits and general receptacle outlets. A typical 3,000 square foot house might require approximately 8,000 to 10,000 feet of 14-2 wire. This accounts for the numerous lighting fixtures and outlets distributed throughout the house. Second, 14-3 wire, which includes an additional conductor for three-way switches or switch loops, is estimated to be around 2,000 to 3,000 feet. This wire is essential for controlling lights from multiple locations, enhancing convenience in areas such as hallways and staircases. Third, 12-2 wire is often used for kitchen receptacles and other high-load circuits. For a 3,000 square foot house, expect to use approximately 4,000 to 6,000 feet of 12-2 wire. This gauge is capable of handling the increased electrical demands of kitchen appliances and other power-hungry devices. Fourth, 12-3 wire, similar to 14-3 but with a higher gauge for increased capacity, might require about 1,000 to 2,000 feet. This wire is used for three-way switches in circuits that demand more power. Fifth, 10-3 wire is typically used for larger appliances like electric stoves or clothes dryers. A 3,000 square foot house might need approximately 500 to 1,000 feet of 10-3 wire to accommodate these high demand appliances. 6. 8-3 wire is used for even larger appliances or subpanels, and you might need about 250 to 500 feet of it. This wire ensures sufficient current carrying capacity for heavy-duty electrical equipment. Summing up the approximate footages of all these wire types gives us a total estimate of 16,250 to 22,500 feet of wire for a 3,000 square foot house. It's important to note that this estimate doesn't include wiring for special purpose circuits like those for HVAC or security systems. These systems have their own wiring requirements that should be calculated separately. Typically, wires are rolled into 500 or 1,000 foot spools. Therefore, the number of spools needed will depend on the specific footage required for each wire type. For instance, if you need 8,000 feet of 40-2 wire, you would need either 8 1,000 foot spools or 16 500 foot spools. Electrical codes, such as those outlined by the National Electrical Code or NEC, specify the allowable ampacity of different wire gauges. Ampacity refers to the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables such as NEC Table 310.15b16 that list the ampacities for various wire types and sizes based on their insulation and installation conditions. For example, 14-gauge copper wire with type THHN insulation typically has an ampacity of 15 amps, while 12-gauge copper wire with the same insulation has an ampacity of 20 amps. Using the correct wire gauge is essential for safety and compliance with electrical codes. Overloading a wire can cause it to overheat, potentially leading to insulation damage, electrical fires, and other hazards. The NEC specifies the appropriate wire gauge for different circuit types and applications to ensure that the wiring can safely handle the expected load. For instance, a 15-amp circuit typically requires 14-gauge wire, while a 20-amp circuit requires 12-gauge wire. When selecting wire, it's also important to consider the type of insulation. Common insulation types include THHN, THWN, and UF. THHN insulation is suitable for dry locations, while THWN insulation is suitable for wet or damp locations. UF insulation is designed for underground installations and is resistant to moisture and corrosion. The choice of insulation depends on the specific environmental conditions of the installation. Voltage drop is another important factor to consider when determining wire size. Voltage drop refers to the decrease in voltage that occurs along a wire due to its resistance. Excessive voltage drop can cause lights to dim, appliances to malfunction, and other electrical problems. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it's often necessary to use a larger wire gauge, especially for long runs. The NEC provides formulas and tables for calculating voltage drop based on wire size, current, and distance. In addition to wire gauge and insulation, it's also important to consider the type of conductor. Copper and aluminum are the most common conductor materials. Copper has higher conductivity than aluminum, meaning it can carry more current for a given size. However, aluminum is lighter and less expensive than copper. The NEC specifies different opacities for copper and aluminum conductors, so it's important to choose the appropriate conductor material for the application. When running wires, it's essential to follow proper installation techniques. Wires should be properly supported and secured to prevent damage and ensure safety. The NEC specifies the maximum spacing between wire supports and the types of supports that are permitted. Wires should also be protected from physical damage by running them through conduit or other protective enclosures. Conduit provides a rigid, protective pathway for wires, protecting them from impacts, moisture, and other hazards. There are various types of conduit available, including rigid metal conduit, electrical metallic tubing, and flexible metal conduit. The choice of conduit depends on the specific application and environmental conditions. In addition to conduit, other wiring methods include cable trays, wireways, and surface raceways. Cable trays are open support systems that are used to support large quantities of cables. Wireways are enclosed metal troughs that are used to protect and route wires. Surface raceways are surface-mounted channels that are used to conceal and protect wires. When making wire connections, it's important to use proper connectors and techniques. Wire connectors should be properly sized for the wire gauge and should provide a secure, reliable connection. Common types of wire connectors include wire nuts, crimp connectors, and terminal blocks. Wire nuts are used to connect two or more wires together by twisting them together and then covering them with an insulating cap. Crimp connectors are used to connect wires by crimping them together with a special tool. Terminal blocks are used to connect wires to electrical devices such as switches, outlets, and circuit breakers. When working with electricity, it's essential to follow safety precautions to prevent electric shock and other hazards. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you're not comfortable working with electricity, it's best to hire a qualified electrician. An electrician has the knowledge, skills, and experience to safely and properly install and maintain electrical systems. When planning an electrical installation, it's important to obtain the necessary permits and inspections. Electrical permits ensure that the installation complies with local codes and regulations. Electrical inspections are conducted by qualified inspectors to verify that the installation is safe and meets all applicable requirements. In addition to the basic wiring for lighting, outlets, and appliances, there are also special purpose circuits that may be required in a house. These circuits include those for HVAC systems, security systems, and other specialized equipment. HVAC systems typically require dedicated circuits with appropriate voltage and amperage ratings. Security systems may require low-voltage wiring for sensors, cameras, and control panels. Other specialized equipment, such as electric vehicle chargers and solar panels, may also require dedicated circuits and wiring. When installing these special-purpose circuits, it's important to follow the manufacturer's instructions and all applicable codes and regulations. It's also important to ensure that the wiring is properly sized and protected to prevent overloading and other hazards. In summary, estimating the wire footage for a 3,000 square foot house involves considering various wire types, their respective lengths, and the specific needs of the electrical system. Factors such as house layout, electrical system design, and special purpose circuits can all affect the amount of wire required. By following proper installation techniques, using appropriate materials, and adhering to electrical codes, you can ensure a safe and reliable electrical system. Remember to always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. Considering the total footage of wire installed in a house, the overall weight can be significant. For example, several thousand feet of copper wire can easily weigh hundreds of pounds. This weight is distributed throughout the house's structure, supported by framing members and other structural elements. When designing the electrical system, it's important to consider the weight of the wiring and ensure that the structure can adequately support it. In addition to the weight of the wiring, the electrical system also includes other components such as circuit breakers, panels, and transformers. These components can also be quite heavy, especially in larger houses with complex electrical systems. The electrical panel, which houses the circuit breakers, is typically mounted on a wall and securely fastened to the framing. Larger panels may require additional support to ensure that they can handle the weight of the breakers and wiring. Transformers, which are used to step down voltage, can be very heavy and often require a concrete pad or other substantial support structure. When planning the layout of the electrical system, it's important to consider the location of these heavy components and ensure that they are properly supported. Furthermore, the electrical system needs to be grounded to provide a safe path for fault current to flow back to the source. Grounding is typically achieved by connecting the electrical panel to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a low-resistance path for fault current, helping to protect against electric shock and equipment damage. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors and the methods for installing grounding electrodes. Proper grounding is essential for safety and is a critical part of any electrical installation. In addition to grounding, surge protection is also important to protect electronic equipment from voltage spikes and surges. Surge protection devices, or SPDs, are designed to divert excess voltage away from sensitive equipment, preventing damage. SPD are typically installed at the electrical panel and at individual outlets to provide comprehensive surge protection. The NEC recommends the use of SPD in residential and commercial buildings to protect against lightning strikes and other voltage surges. When selecting SPD, it's important to choose devices that are rated for the voltage and current of the electrical system. It's also important to ensure that the SPD are properly installed and grounded to provide effective surge protection. The complexity of an electrical system in a 3,000 square foot house can vary depending on the number of circuits, the types of appliances, and the specific needs of the occupants. A house with numerous electronic devices, such as computers, televisions, and gaming consoles, may require more circuits and outlets than a house with fewer electronics. Similarly, a house with a large kitchen and numerous appliances may require more circuits to handle the increased electrical load. The electrical system should be designed to accommodate the current and future needs of the occupants. It's often a good idea to install extra circuits and outlets to provide flexibility and avoid overloading existing circuits. Overloading circuits can cause breakers to trip, which can be inconvenient and potentially dangerous. When designing the electrical system, it's also important to consider energy efficiency. Energy-efficient lighting, appliances, and other electrical equipment can help reduce energy consumption and lower utility bills. LED lighting, for example, uses significantly less energy than traditional incandescent lighting and can last much longer. Energy Star certified appliances are also designed to be energy efficient and can save money on electricity costs. When selecting electrical equipment, look for products that are energy efficient and that meet your specific needs. The cost of wiring a 3,000 square foot house can vary depending on the complexity of the electrical system, the type of materials used, and the labor rates of the electrician. The cost of wire can range from a few cents per foot to several dollars per foot, depending on the gauge type and conductor material. The cost of other electrical components, such as circuit breakers, panels, and outlets, can also vary depending on the quality and features. Labor costs can vary depending on the location and the experience of the electrician. It's important to get multiple quotes from different electricians before hiring one to ensure that you're getting a fair price. When comparing quotes, be sure to ask about the scope of work, the materials used, and the warranty provided. It's also important to check the electrician's credentials and ensure that they are licensed and insured. The electrical system is a critical part of any house, and it's important to ensure that it's properly designed, installed, and maintained. By following proper installation techniques, using appropriate materials, and adhering to electrical codes, you can ensure a safe and reliable electrical system for years to come.